Greetings from Berkshire Guitar Amplifier Repairs in Reading, England. I'm Stuart Smith and I'm quite excited today. I've got a very rare and unusual amp to show you. It's a Selmer Thunderbird 50 Mark II. Never seen one before, never had one in a workshop. It's from about 1968. So let me see, that was made when I was about 15, which is quite a long time ago now. Let's have a look at the amp. The customer wants a complete overhaul of the amp and to have it brought back up to scratch. He's willing to spend a bit of money on it. So the first thing I'm going to do is to assess the condition and get back to him with a report on the amp. This will be a longish video, I expect, as I refurbish the amp, and hopefully you'll want to watch it, but if not, time to turn off now because this will be quite long and quite involved, and I expect there will be a fair bit that needs doing to the amp. Anyway, enough of me chatting. I'm sure you're dying to see the amp. Let's have a look at this little beauty right now. Well, take a look at this. What an absolutely stunning example of this amp. Grill cloth looks original. It's still got the original Selmer decal, and they often get broken. Look at those piano key tone controls there. It reminds me of the old Grundig radios from the 50s. A couple of the knob shiny bits are missing. What have we got here? We've got presence, we've got reverb, tremolo. Standby switch is broken, look. Power switch, and you can see why they're broken off. There's no depth between here. That amp's only got to be laying down on the front or fall over once on its front and they'll snap off. That's just simply bad design. And there we go. What condition is the cabinet in? Not too bad at all, actually. It's worth a fair bit of money, this amp. I would guess about maybe as much as £2,000. Not sure what's gone on the side there. There might have been a tilt leg. Let's have a look round the back. Okay, we can't see too much round the back here. I notice it's quite Fender Twin-like in its tremolo and reverb and input and output for the foot switch. Extension speaker, voltage selector. Got the fuses on the back there. HT fuse and a couple of Goodman Selmer 30 watt speakers in there. Foot switch is lurking in the back there. Right, well, let's have a little think what we want to do with this amp. I think we can take a view on this. We can either try and power it up slowly and see if it works, or we can just take the chassis straight out. Let me think. Okay, the decision's made for me really, because these switches are broken off, so we can't probably even turn the amp on properly. So I think let's just take the chassis out and see what we have here. Okay, so I've got the back off. That was just 6 screws, came off quite easily. I've made a note of where the foot switch and reverb go. That's always a good thing to do. You think you'll remember, but you won't. And I've just unplugged them all from the back here. And there's the foot switch one, so I've just taken all that out. What else we're going to do? That's interesting. The speaker. Oh, speaker's soldered on, so I'm going to have to unsolder the speaker connections. What else? That's about it, I think. Oh, the reverb must go somewhere. Here we go. Oh, I've disconnected that, and that's the reverb. Good. Look at the dust in here. Absolutely thick. Oh, that's really thick dust. And that's the reverb pan on the bottom there, would you believe? Yeah. Right, so I'm going to unsolder the speaker. Then I'm going to turn the amp up on its side here and take out these 4 screws here. 1, 2, 3, 4. And I'm hoping then that the chassis will just slide out and we'll be able to get the chassis up on the bench, and I'll be very interested to see the condition of this inside. I wonder if anything's been done. In fact, we can, look, these are the original Pinnacle EL34s in here. I'll be fascinated to see what we've got in the way of preamp valves. I'm wondering if this amp's ever been touched, whether anything's been done to it. Anyway, let's do that. I'll desolder the speaker leads and then pull out the chassis. Right, well, the chassis came out like a dream, no problems whatsoever. I thought I'd just give you a quick scan along the underside here without saying anything. There you go. Now my view is that this is all original. I can't see anything that's been changed on this amp. It's exactly as it was made in 1968. These old style power resistors here. We have, this is the bias circuit, look. So we have a 50 microfarad cap and this old fashioned diode here. What else have we got? These are very common capacitors back in the day. I won't be changing any of those. They'll almost certainly be okay unless any of them are leaky. This is the back of the piano key tone setting. So we've just got a load of tone components on here. This is interesting. This is the Tremolo circuit. So we have a flashing neon light and an opto light dependent resistor, not enclosed in anything to stop the light. I guess it must be dark enough inside here that they don't worry about that. That will almost certainly have gone. We have some other electrolytic capacitors here, and in general the thing looks in fairly good condition. So what am I thinking of in terms of renovation at this early stage? Well, all the electrolytic capacitors have to be changed. So that's that one, those two, definitely the bias capacitor. Here are the big smoothing capacitors which do the HT, and they look pretty good. There is no sign of any leakage there. I'm going to get the eyeglass in there at some point, but they look good to me. I'm tempted to leave them if I can. I know they're 1960s, but if they're doing the job when I power the amp up, I'm tempted just to leave well enough alone, because they are original. I want to leave the amp as original as possible. This is a vintage amplifier, so my approach to these amps is to do as little as possible. Certainly won't be changing any of these tone capacitors, as I say, unless they are leaky, unless we're getting some trouble. Okay, so actually this is looking in quite good condition, this amp. So that's not too bad. Let's flip it over now on the other side and see what valves we've got inside. I'll be fascinated to see if they're all original, and I think a full revalve will definitely be on the cards for the amp. Here are the two big smoothing capacitors here, and they're Plessy. There's the rectifier valve. What is that? It's got no number on. I might have to look that up. Here are probably the two original Pinnacle EL34s. They will definitely need changing. Right, here's the fun part. What have we got under here? We have a Brimar 12AX7 in the phase splitter, almost certainly original. We have a Pinnacle ECC83 here, original. Another Brimar, an original valve. Another Brimar, original. Another Brimar. This amp is stock. Nothing's been touched on it. This is the reverb transformer, by the way, that goes between the amp and the reverb pan. At some point in the future I will check the reverb pan to see if that's working, but I'm not worrying myself about that now. Right, so once again I'm going to ask the customer what he wants to do. I would almost certainly want to change these power valves, and the rectifier may be okay. Rectifier valves very rarely go, and they certainly don't need changing routinely when you do a revalve. And then we need to take a view on these Brimars. I will probably put them on the valve tester. In fact, I'll do that now. And if they test good, do you know what? I'm kind of tempted to leave them. They're original tubes, stock as this was made in 1968. If they come out good, what's the point in spending money and changing those for brand new tubes? Funnily enough, if this was a newer amplifier, like 1980s, I would change these tubes just to put a new set of tubes in. But we have a bit of vintage equipment here, so I'm taking a bit of a more circumspect view on it. Well, let's make that the next job then. Let's get the valves tested and I'll report back to you on their condition. Right, here's the report back on the tubes. All of the 12 AX7s tested good on my orange valve tester, which is what I use for preamp tubes. I've got a better tester than that for power tubes. I'll come onto this one in a moment. The power valves, they were quite mismatched on my tester. I'm sure they still work, but I'm going to suggest a new pair of power valves. This little chappy here is a 6BR8, quite an unusual valve. I expect it's okay, but I'm going to put a new one in because they're getting quite hard to get hold of and getting rarer. So as this one's like 50 years old, why don't we put a new one in and keep this as a spare? Because in, I don't know, 5 or 10 years time it might be quite hard to get hold of a replacement for that. They're about £20, so I think that's probably worth spending money, especially as we're probably not going to revalve this now. So that's the situation with the valves. I'm guessing this amp hasn't really been used very much, maybe for 30-40 years, and then maybe only lightly when it was actually in service. I'm sure you know it doesn't matter how old a valve is. You know, this could be 100 years old, this valve, and if it had never been used, it would be as good as new. So it's the amount of hours you clock up on a valve which causes the wear. Just like car tyres, it's the amount of hours you run the tyres for that causes the wear. Not having a new tyre in stock for 50 years and taking it out. I don't know whether that applies to rubber. Anyway, there you go, you get the idea. Right, so I'm going to push on now with the report for the customer, and the work on this amp is not looking as much as I thought it would be. I'm going to suggest he changes all the internal small electrolytic capacitors. I'm going to suggest that I change the diode on the bias side. I'm going to suggest a new valve here and a new pair of power valves. Then we're good to go, providing that the reverb and the vibrato work, which is a big if on an amp like this. I don't expect the tremolo to work. I expect that light dependent resistor to have degraded with age, and we don't know about the reverb tank. In fact, I think I'll make that my next thing. I'm just going to measure on the leads of the reverb tank to see if we have any kind of continuity back to the transducers on the reverb tank. So let's do that next. Okay, let's measure the transducers on the other end of these cables here, which go to the reverb tank. One of them will be fairly high impedance, that's the return. So let's select 200k, I don't know which is which at the moment. Let's have a look. We've got an open circuit on there, nothing. And on this one we've got a lowish impedance, that's probably the send. Yeah, that looks good to me. It's about 160 ohms or something. So that's the send side, but we have an open circuit on the return side. Now at the moment that could be anything. That could be this cable, it could be the transducer at the other end, the wire could have dropped off the reverb tank, we don't know. So we may need a new reverb tank on this. I'll have to pull the reverb tank out and have a look at it. I won't do that now. I think I'll just flag to the customer that he may need a new reverb tank. Good. Right, well the next thing I think is to send a report to the customer with some prices and make sure he okays the work, which I'm sure he will, because there is much less work than I thought there would be, and I'm sure much less than he thought there would be. So let me do that, get the okay from him, and then we can push ahead with the repairs. Okay, well I thought I would have a go at bringing this amp up as it is to see if we get anything out of it. I always like to check that, because if the amp works basically and then you do some work on it like changing a lot of capacitors and it stops working, you know you've done something wrong. But if you just dive straight in and start changing components and then power it up and it doesn't work, you think, oh, well, was that what I did, or was it not working to start with? So I like to see if an amp is actually basically working. Let me show you the setup I've got here. I've got all the original valves back in, including the Pinnacle EL34s. I've got two bias meters set up, one on each valve, so that I can monitor the bias current. I've got a voltmeter set on 750 volts, on which I'm monitoring the HT on the HT cap, so I want to see if the HT comes up. And then I've got the amp on a variac here, which allows me to wind up the voltage slowly. So let's do that. I want to see if the light comes on first of all. I'm just winding it up. Aha, good, we've got some, yes, we've got a bit of an indicator light there, so that's a good start. It means we're getting power through to the amp. I wouldn't expect any HT yet, because the rectifier valve is not yet working. So we've got about, what have we got there, 86 volts AC. Let's wind up a bit more, like 130 volts. Oh, we've got some HT coming up here, look, 240 volts. And are the output valves drawing current? Yes, they are. Not much, but we're on quite a low voltage. This is actually looking quite promising. I've got a speaker and a guitar connected as well. Alright, well let's continue. Let's go up to 170 volts or so. Oh look, this is very nice. The output valves are drawing current now. I can also hear a hum from the speaker. And our HT is up to 330 volts. This is looking actually quite promising. Let's see if we have any sound. These valves are drawing a fair bit of current, actually, 45 milliamps, and rising. That's quite high considering we're only on 174 volts, so I don't want to go much higher than that. In fact, I might just back this off a little bit. So those valves definitely need biasing. They're also mismatched, but I knew that because I put them on a tester, and these Pinnacle valves are pretty much shot. Alright, well let's strum the old guitar. Oh! Well that's great. Hey, we have sound coming out of this amp, that's fantastic. Nice, nice. Oh, those pots are really scratchy. Okay, that's good. I haven't tested anything like Vibrato yet. That will be the next thing to do. Where's our little Vibrato cell? Oh yes, that might need the foot switch to turn on that light and get that flashing. But anyway, I'm not worried about that. So yeah, we're drawing a fair old current on these EL34s, 50 volts already. If I were to take that up to 240 volts, this would go up much higher. So that might be something to do with this bias part of the circuit here. So I think one of the first jobs I'll do is change that cap and that diode and get the negative bias working properly. But hey, this is looking fairly promising. I think I will quickly test the vibrato by shorting the vibrato tremolo. I never really take much notice of the difference. By shorting this socket to ground, I think that should hopefully turn on the tremolo. Let's have a look, see if that works. Well, how awesome is that? Look, I've just shorted the tremolo foot switch to ground and our little lamp's flashing. I don't suppose it's making... it won't help having all this ambient light on this opto sensor there, but I wonder if we've got any tremolo. I can't hear anything. What have we got this? Tremolo, speed and depth. Let's turn the depth up full and speed down. See, the light's flashing nicely now. But as I say, we've got huge ambient light on this opto, so I wouldn't really expect that to work. Yes, I can hear the slightest, smallest of tremolos there. What can I do? Let me just turn the camera off a sec. Right, I've put an old tea towel over the tremolo section in an attempt to get some kind of darkness in there. And it does actually work, surprisingly. You can just about hear... Whoa, 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 whoa. So that is kind of working. My guess is that opto element will need replacing. They don't last very long, those. They've got some sort of coating on them. I think it's some sort of sulfide coating, and it does degenerate with age, so I will see if I can find something to replace that with, and I think that will probably bring a tremolo back to life. But what that means is the tremolo part of the circuit's working fine. So that's great. Hey, we're on a kind of roll here. Do you know what? I'm tempted to hang a reverb pan off here and see if we can get any reverb. Okay, we're set up to test the reverb here. I've got a dual RCA phono lead, just one side connected at the moment, and a good way to test the reverb is just to turn it up, which I have, and see if you get any signal coming back, which we are. So that means that the circuitry on the amp is correct. Now if we plug this into the output, which is that this one here, I think, so that should be, I think that's the output. There we go. I mean, this might not be anything like the right reverb tank for this, but we've just proven that the circuitry on this side of the reverb, in other words the receive, works. Let's now plug the send in and the send here. Will we get any reverb on the guitar? No. Not a peep. Okay, so there's a problem with the reverb. No, nothing whatsoever. But on the receive side we have. Okay, so there's a bit of a problem on the reverb. I think the foot switch is the correct sense. I think no foot switch means the reverb's on. And grounding that turns the reverb off, I think. I think that's correct, just to make sure. Yeah, we've got nothing now. So grounding that RCA turns the reverb off, whereas grounding the other RCA turns the vibrato on. Go figure. Okay, we are on quite a low voltage still, 164 volts. I think I'm just going to have jury out on that reverb for the moment, whilst I get the current sorted on these output valves. So I think the next thing I'm going to do is change that 50 microfarad capacitor on that diode, and see if we get a better situation with the negative bias. If we don't, I'll pop in my new EL 34 tubes and take it from there. Then we can get the voltage up to what it should be, and then check the reverb again. Okay, so the first thing we're going to do is to change this bias cap here. Everything's turned off, caps are discharged, amps unplugged. I'm just going to cut this out of here. Put it there to remind myself which way round it is, which is positive at the top, negative at the bottom. And we're going to put this in here. Just going to make a little J hook there to hold that in. That. Good, now we can solder that. Good. That's on that side, and the same sort of deal on this side. Solder that one in. Excellent, that's that done. That's right, that'll do. That's the right way round, correct. Now we're going to change this diode here. It's probably working perfectly, but this is a very old diode. So let me just go and grab one from my stock first of all. Okay, so I'm going to just double check the polarity of this diode. I think this is the bar here, or the cathode, and that's the anode. So we should get a reading if we do this. Correct, half a volt or 0.6 kind of thing. And now I want to make sure that my replacement diode, the bar, is down here. So again, let's make sure that that is correct in terms of... Yep, that's correct. So if I put that in there, we're good to go. Let's do that then as the next job. Well, this side's quite easy. We can just cut that out. This side's not so easy. You're going to have to solder on somewhere. Put that there to remind me. I think I might just go on here actually. So we need to go like this and then like this. I want to do something like this. I'll sort that out in a minute. And then here we'll just go around here like that. That's perfectly good enough. Cut that off. Now we can do something with this. Not exactly sure what. I think something like that's fine really. Not particularly elegant that. I don't really want to sort of try and get another contact into here. But this is okay. Okay, that's alright. Cut off the excess, and that's okay. So now we're going to fire up the amp again and see if we're in a slightly better situation regarding bias. Okay, the good news is that definitely did the trick. We're up to full voltage on the mains in, and we have about 40 milliamps, 34 milliamps on this power valve. So that's great. There was a problem with the bias circuit, that's fantastic. So what I'm now going to do is put the new JJs in and see if we can get this amp biased up. Okay, the way they derive this bias is, I think, by taking a little sniff of the HT through this capacitor here. But anyway, bottom line is, to decrease the bias current we have to increase the value of this 39k resistor here. So we want less bias current, we increase the value of that. And I've got this connected clipped across. I've chopped this resistor out here, and I've got this connected to my resistance decade box, which is just off camera, and I can dial in different values of resistor. So at the moment, kind of slightly upside down, but we've got 450 plate volts and 32 milliamps. That's because I've got a 49k resistor dialed in. The correct current we want is 38 milliamps, so it's quite sensitive actually to. So that's a 47k I've dialed in, and I'm actually very happy with that. 38 milliamps is perfectly okay. And that's the new pair of JJ EL34s. Good, so I'm going to swap that resistor from 39k to 47k, and that will be job done on biasing this amp. Great, we're making good progress. Okay, there you go, I've soldered in 47k there. I'm just turned it on to make sure that the bias current is still as we expect it to be. Where are we? Coming up nicely, look. Yep, that's going to be fine. Good, that's job done on the bias, look. 440 volts, coming up to 35, 36 milliamps, creeping up there. Good, happy with that. Right, well the next thing I'm going to do is to change these electrolytic capacitors, these three here. I won't show you all of them, because if you've seen one, you've seen them all. So let me just show you how I do that. First of all, make sure you get the capacitor the right way round, and in this case the positive is down this end. There's a plus sign, there's a little indent in the capacitor, and there's a little indent in my replacement, negative pointing up towards there. So I'm just going to lay that down there in the right orientation, and then I'll just clip this one out, leaving a little stub. And now I can just bend the stub up like that, and that allows me to wrap the new capacitor around. So I'm just going to lay that in there. Make a point of making the value of the capacitor uppermost, so that the next person in there can see what's going on. And we can just literally wrap that around there like that, and wrap this around here like this. Just use the pliers on this one. There we go. We can solder that in now. There we go. Clip off the excess lead. Making sure to hold on to the bit so that it doesn't go flying off somewhere. And that's job done on that capacitor there. So I'm going to do these two here now. Then I think the next thing I'll do is have a little look at this opto maybe. I've also got the pots to service, so I'll show you how I do that. I've changed those three capacitors now, 1, 2, 3, so we're good to go there. I thought I'd have a little investigation of this opto cell here, and I think you might find this quite interesting. I've got the meter connected to the opto cell, reading its resistance. At the moment it's 20k or so. So watch what happens when I put my thumb over it. It goes up to 50k, and if I point my bench light at it, it goes down to a nice kind of 2.3k. So I think that opto is actually not too bad. I don't think it needs changing. I'm wondering why they've got this light so far away from it. I'm kind of tempted to bring that a little bit closer to the opto. And then also I think when this is dark, we'll test it again in a moment, when this is dark in here, that might work a bit better. We can put a piece of cardboard over here or something and make it as dark as we're able to. So I think I'm just going to move this neon light a little bit closer to there, maybe sort of half the distance between it, and then we'll put some material over here and try and get a dark situation and see if we're happy with the depth of the vibrato. I thought you might be interested to see what I've done here. I'm just waiting for the glue to dry. I've put a little block of wood there, araldited that on, and araldited this neon light to the block of wood, and that's now, as you see, a lot closer to the opto. So when that glue's dried, I'll just bring a wire down to the two terminals here. If this doesn't work, I can easily just break that off and we can revert back to square one, but I think it'll be interesting to see what this does. Okay, I've got the neon light in there and the glue set, so I'm just going to put this piece of wood over the top to make it a bit darker. You can hear that click 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 sound, which is quite typical of these opto tremolos. Actually, it can be a bit of a nuisance to get rid of, but let's see how good the tremolo is. Well, I can hear it. That would to me be about sort of 50% on a Fender of the depth. So I think what I'm going to do is just try swapping the opto for a new one. I've got again, I bought a job lot of these light dependent resistors of various values, and we can just pop a new one in. I've got one here. It's quite a bit smaller than the existing one. It's a tiny little thing actually, so I think I might just tack that in and see if that improves matters. I don't want to spend too long on this, but we'll give this a go since I happen to have one in stock. Okay, there you go. I've put the new opto in. I've put it quite close to the light there. So let's turn on and see what happens. I have no idea what will happen. It may or may not be an improvement. There you go, the light's flashing now. There we go. Took a while for that neon to strike actually, quite interesting. Alright, well that's obviously we have all the lights on. Let's just see what... Oh, that's a lot better already. We've got full light on here. Oh ho ho! Listen to that. Oh yeah! Proper tremolo. That's great. That's improved it at least twice as much. That's fantastic. I've got ourselves a nice little setup there actually. Quite pleased with that. No idea why they put that so far away. I think that's a bit of an improvement. Good. So the next thing to do is to service the pots. I'll just show you how I do one of those. It's very straightforward. So I just use some Deoxit D5, and our life has been made very easy here because these are quite easy to get to and quite open. Okay, I'm just going to give it a little squirt in here, little drinkies. Good. I'll just do the others now. I won't bother showing you those. Right, having sorted out the tremolo, a bit of an update on the reverb. I've got the reverb tank plugged in. If you remember, we last left it where we were at 160 volts and we had no reverb. We're now on full voltage. I've got the reverb turned up full. When I waggle the reverb tank, you get some hideous noises, but there's absolutely nothing in the way of reverb coming through. There's not even a sniff of reverb there. Absolutely nothing coming out of here, so that needs looking at. We also know that the reverb tank on this is open circuit, so that's the second thing. But the bad news is I've noticed something else as well. Our output tube's drawing normal current, HT's there. We can hear the guitar, as you know, look. But it's very quiet. I've got the volume up full there. There's no master volume or anything like that. What have we got here? Tremolo, reverb and presence. I haven't tried any of these piano keys, but they're just tone. So we don't have much volume through this guitar. And it's a little bit distorted, so we're going to have a look into that. So literally about 5 seconds after turning the camera off there, I thought, hang on a minute, this is flooded with light on that opto sensor. Is it just the fact that the light is hitting the opto sensor and turning the volume down? Because that's what it does, of course. Every time it gets a light on it, its resistance goes down, and that's effectively shoved across the volume control so that the sound goes up and down. So I'm just going to point the desk lamp at the opto. There's no volume there at all. Now what happens if I do this? Oh wow. So listen to that. With the piece of wood, without the piece of wood. Oh my god. There's almost nothing there. So I'll strum the guitar now. Turn the light out, comes up a bit, put that on, comes up a lot. I think that's probably okay. I will do a power test on the amp at some point to make sure it's putting out approximately 50 watts. So, right, well that was a funny one, wasn't it? I'm glad I didn't get too involved there. Right, what's next on the amp? I think we're nearly home. I'm going to clean the valve sockets. I'm going to take the valves out and just put some deoxit in there. It's not too bad actually. I'm moving them around. That's a little bit scratchy. So that's easy. That's an easy job. And then what else? Oh yes, of course. I nearly forgot, I've got to order a couple of switches here for the broken off mains and HT switches. So what I want to do is have a look at a picture of the original amp and see what kind of switch lever that had, and see if I can find something that looks at least a little bit like it to replace those. So that's got to be done. We have to change the two switches at that end of the amp for new. Rightio, right, well I'll leave it now. It's getting on a bit, time for my dinner, supper, whatever you want to call it, and I'll pick this up again tomorrow. Okay, I think the next thing we need to do is to have a look at, see if we can get this reverb sorted. The current state of play is I've got it plugged in to a remote reverb pan, and we've got reverb return. So when I bang the pan you hear that, but we've got no reverb send. If I strum a guitar chord, there's absolutely nothing going off to the reverb there. Now the reverb I think is done by this strange valve here. I'm just going to pull it. Ouch, it's hot. This 6BR8. I'm not sure I've come across one of those before. And having pulled that valve, it's made no difference to the amp, so I think that is the reverb valve. I did order a new one and that has come in, so I don't think it'll be this valve, but anyway, let's pop it in and see if that does anything. Somehow doubt it, but we'll give it a go. So we've got a new Sylvania 6BR8. Okay, well, there we go. Let's pop that in. There we go. Just let that warm up a moment. No, nothing there at all. Righty-ho. So this is the offending section here. Let's have a look at that resistor. I'm not sure what that is. I'm going to turn the amp off. That is looking quite old, that resistor. That's 100K. Alright, well, let's have a look. It's the only component I can see around there. I've checked the reverb transformer, which comes out here. It has this black and yellow and pink and red. There's the primary side, and the black and yellow quite simply go to the reverb to the reverb here, and they've got sensible readings on, so it's not the reverb transformer. Not a lot else it can be. Let's try this resistor. Okay, bit kind of inconclusive, that. Interesting. I'm on 200K. I think I'm on the terminals here. Interesting. I wonder if that's open circuit. I think it might be, you know. I'm kind of wiping up and down to wipe off any gunge or corrosion on there. And I'm not getting anything there. Okay, right, alright, interesting. I think I'll desolder that and put in a new one. Oh, we should be so lucky, eh? I don't think so. Let's make sure there's no voltages around on this valve here before I get too keen there. Nothing sensible or nothing going to bite us there. Right, well, I'm going to unsolder that resistor and take it out and measure it. So it's going from pin 1 to 2. I need to remember that. I'm not familiar with this valve, so I don't know the pins on it. Right, well, there we go. It's looking very old, this. I don't think I've ever seen one like that before. That looks horrible. Oh, I wonder if that's the capacitor. I'm sounding very ignorant here, aren't I? 100kN. Could that be 100k, 100,000 nanofarad? No. 100kN. What does that even mean? Huh. I think I'm going to have a look at the schematic here, because I don't actually recognise what that component is, which is quite surprising, having worked on hundreds of amps. I mean, if that was a resistor, you'd expect it to be colour coded. 100kN. It wouldn't be 100,000 nanofarads, because that would be a very big capacitor. That's not that big. Okay, I won't ruminate on screen. I'm going to have a look at the schematic if I can find it and see what goes between pin 1 and pin 2 of this 6BR8. I will come back and let you know. Okay, just a quick update. I've been chasing my tail on the reverb. I had a couple of bad phono leads. My twin phono to phono leads were open circuit on one, which didn't help. I spent about an hour trying to find out what was going on there. Anyway, I'm going to put this bit of board over to bring the volume back up. And I've got my reverb pan connected here. I think we'll just zoom out a little bit on this one. There we go. I've got my reverb pan connected by some good phono leads now, and you can hear that we have reverb. This isn't the right pan, but it doesn't matter. So the reverb is working, and the problem is with the reverb tank, which we will need to investigate. Now, I'm not going to do that now. The next thing I want to do is to change the two switches in the front, the off-on switch and the standby switch. And I thought I'd show you something curious about the standby switch, because it took me a while to work out what on earth was going on with it. I'll just show you this quickly. Let me zoom in. So here's the schematic look. HT comes in here. It's a double pole standby switch, so that switch and that switch are the standby switch. Goes off to the power valves, look, so the standby switch doesn't kill the power to the power valves. They're running full steam all the time, very weird. When you switch it switches in this 27k resistor and 16 microfarad. And that does nothing until that's switched, and of course they're ganged together, so that switches, and this switches only the power to the phase splitter. So basically the standby switch kills power to the phase splitter. Everything else, all the other preamp valves and the power valves, have got HT on them all the time. How weird is that? Go figure, why on earth did they do that? I cannot begin to imagine. But anyway, that's how it is. So I've got a couple of new switches. These were a little bigger than I wanted them, but I've offered them up, and I think they'll go in okay. And they're nice heavy-duty switches too, so they'll do the business. So the next thing I'm going to do is to get those in, I think, and then the amp I think is good to go. We'll do some final tests maybe. I want to check the power output, and then finally we have the reverb to sort out, which will be a reverb pan problem, and that will either be a fallen off wire or the reverb pan needs changing. So I'd quite like to make this little photo cell area dark here. Fender, as you know, put the photo cell in a piece of sleeving like that. It's heat shrink sleeved and dark. They put the opto cell and the neon in a piece of black heat shrink sleeving. This is all completely open to any light that creeps in. Again, not a good piece of design, but it's not going to be particularly easy to make that dark there. I don't know, I'll have a think about that. It's obviously dark when it's inside the amplifier, that's how they designed it. So maybe we'll leave well enough alone there. Anyway, next thing is to get these switches changed on the front. So I'll show you how we do that, and that will be the next little job on this amp. I'm quite anxious to get this one off the bench because I've got quite a few amps waiting now. I'm going to make a start now on changing these two switches, and I'm having a little bit of a think. What do you think about this? We've got here a simple single pole, single throw switch for the mains, and I do happen to have one in my parts box, quite kind of similar. This one obviously had a black lever on it. So there's an option there of putting that in, but I don't have something that looks like this in double pole double throw for this HT switch here. You can see there's an altogether bigger switch. So I'm kind of humming and hawing here. And the other thing is, these are cheap and cheerful switches, these. I've actually had this since about 1965, the switch. Shows how old I am. It still does work, but we're switching 240 volts here with this, and I don't think this switch is really up to it particularly. So although it would be kind of more authentic to have this switch, that wasn't a very good switch to start with, and it's completely different to this one. So the other switches I've got are, as I showed you a moment ago, I've got two of these. Now this is a proper switch, this will do the job very nicely. especially if for this switch here I bridge these two poles here, and we'll use both poles of the switch to switch, which is good. And we need a double pole, double throw on this one, and so this one will do it too. And this is an HT switch, so it's switching 300 or 400 volts DC. Now, I don't like switching 300 or 400 volts on this type of cheapo switch. I like a fairly decent switch, so I'm kind of coming down on the side of ignoring authenticity and putting in these two switches here, which are quite large, but I think they'll look okay there and there. I guess if some purist in the future wants to put this amp back to stock kind of thing, they can find a switch that looks a bit more like the original with a short black lever. It's not particularly easy to find exactly the switch you want. The right size lever, maybe a black lever as well, the right number of poles and what kind of thing. It's can be a bit of a mission. So I think I've decided, whilst I've been talking to you, what to do. I'll put these two switches in here, and at least they'll match, which will be good. Okay, well, let's make a start at that. Okay, I've made the amp safe, it's switched off, caps discharged and so on. So we'll just unsolder this switch here. I've already loosened the nut on the front. There we go. As you can see, that's a nicely broken off shaft there. That's because the shafts extend out the front here, and there's no protection on the front when the amp falls over. It just breaks off the thing, and that's a very cheap and cheerful, very low quality main switch. So the one we think you're putting in is 5 times the quality of that. Right, so the thing is, will it fit? Let's have a look. The hole might be the wrong size. It doesn't quite fit. It's a little bit small, the hole, so I'm going to have to get in there with my trusty round file. There we go, Exhibit A, and file that off a bit. So I'll do that now. I won't do that, it makes a horrible noise, and you don't need me to show you how to file a hole, so I'll just go around briefly with the file and see if we can get the switch to fit. Well, that was actually very easy, just took a couple of minutes. The reason being, there's a Perspex front panel here and a mild steel back panel, and the Perspex front panel hole wasn't as big as the one in the actual steel, so I just had to file around the Perspex, and that took hardly any time. So now the switch fits fairly well. What do you reckon? Should we put it in that way, or should we put it in the other way? Let's put it in the other way. Now before I get too enthusiastic, it's quite a big switch here. Let me just actually check this does fit. Yeah, that's going to be great. Good. Goody. So what I'm going to do now is, before I put the switch in, I'm going to link the terminal so that we can use both poles. Quite handy having this piece of hardboard here. I'm going to link there and there and there and there, just because we can use both poles of the switch. So I'll take a little bit of tinned copper wire, bend it into a little J, and we'll just go around here. And I cut that off at about the right length. Maybe there. Now we can just bend this round here. Pop it through there. There we go. I'm going to do the same on the other one, and then I'll solder them. Okay, there we go, we've got the bits of wire in. So now we'll just solder. Obviously this is much easier to do before you put the switch in. Good. One side. Great, there you go. That's fine. So now we want to, the switch will be between here and here obviously. Now what I would do now is to put the switch into the on position, because we want to make sure we get it the right way up inside the case. So by my reckoning the on position should be that way. I always think of the things being thrown across there, but I always will also check that. So let's just do a quick check here. Right, so we should have a short circuit between here and here. We do. So that's the on side, and just to check, of course, the off side is here. There's nothing there. Right, so that switch is now in its on position. And we want to make sure we put it in the chassis the correct way round. So in this case, on is that way. So we'll pop it in there like that. That's good. There's quite a bit of clearance there between. That's the negative of the capacitor of the HT cap anyway there, so that's not high tension there. Otherwise I'd be slightly concerned about that gap between there and there. But as it happens, do you know what? Just for the sake of purism, why don't we just bend this in a little bit here, like that. There's plenty of gap there, but that's even better. A nut on, just to hold it. We'll tighten that up in a moment, and then let's just solder these two wires on here, and that's the mains switch done. I'll just quickly tin those again. Right, what's the easiest way of doing this? Probably probably this way. So that one goes down onto there, and may as well put this one onto here. Like so. Great. Now in theory, not in theory, in practice, there's 240 volts AC between here and ground, but there's quite a bit of clearance there, so I'm not bothered about that at all. That's fine. If that was HT, I'd be slightly concerned, but not that concerned. So we will now just tighten up the nut. There we go. And there we go, job done on the main switch. The first thing I've done is to make a note of how that HT switch is wired so that I can remind myself. I've got a blue and a black wire going to it. I've got this 27k resistor, I'll check the value of that, and I've got this white wire here going off. There's one switch from there to there, and there's the other switch from there to there. On our new switch, that is going to be one switch here to here, one switch here to here. These won't be used. So again, we want to get this in the right way round at some point. So I'm going to take a quick picture of that just to remind myself. I'm going to double check that my diagram is correct, and then I will put the new switch in. Right, I've got the switch out. It makes life easier. So here is one switch from there to there. Here's the other switch from there to there. So let me just check my diagram. On one side of one switch I've got a black, and it goes to 27k. Black, 27k, one side of the switch. The other side of that switch goes to white. Well, if it goes to white, that's okay. On the second switch I've got a blue coming in there. The other side of the switch goes to the other side of the 27k. So yep, I'm happy with the diagram, happy with the wiring there, and we can now proceed to wire up our switch. I think I'll just check the value of this 27k. It's quite an old resistor. I might even pop in a new 2 watt 27k if I happen to have one. Right, I've filed out the hole on this one, and this switch now fits, which is good. So I'm just going to tin the connections on here. Doesn't matter which 4 we pick. There we go, 1, 2, 3, 4. We'll orient the switch now. We could obviously do this later, but I reckon when that's down, that's connected to there and that's connected to there. That's the usual arrangement. Now let's transfer these 3 wires and 1 resistor. Okay, I don't have a 27k resistor at 2 watts. Measuring it on my other multimeter, it comes out at anyway, that's 29k. Okay. You know, I'm not happy about leaving that 29k resistor. The trouble is that's taking the current for the phase splitter, and 29k means that the voltage on the phase splitter plate will be less, significantly less, you know, maybe 10% less than it would be. So anyway, I don't have a 27k resistor, very annoying. I've got pretty much every other value going. So I've got a couple of 56k's here, look, which I'm planning to put in parallel, and you'll see that they measure 27.8k, 27.5k, which is perfect. So that's the plan. We'll put 2 of those in. So what I normally do is that kind of thing if you want to make up a parallel resistor. There are various ways of doing this. This is just my way. Now we can just solder this here. Like that. And if you want to put the resistor in kind of, you know, axially like that, then I would use these 2 and just chop off those 2. But if you want to put the resistor in kind of more vertically, then you can just chop off these 2. Let's have a look. I think we probably want to go for the more vertical option, so I think we'll go in here like this, and that means chopping off these ones here and this one here. So this needs to go across to here, look. Ouch, I keep burning myself as well. I don't know why you're watching this. Bloody amateur stuff, really, isn't it? Can't even solder a resistor across a switch. Oh, it's a great big wasp. Is that what that buzzing noise you can hear? right by the camera. Okay, now, there we go. Right, so. Okay, so there's a switch from there to there, and there's a switch from there to there, and this is going across the two switches. Correct. Right. Now the black can go on whichever one of these we like, so whichever's easiest really. We'll just put it onto here. There we go. And okay, now here's one switch here. On one side of the switch we have a black and a resistor. Black and a resistor on one side of the switch. The other side of that switch must go to white. So that's there. There we go. And let's check the other switch now, which is this switch. It has a resistor going onto it at the moment. Yes, it does. And the other side of that switch goes to blue. We have a blue. There we go. We're on there. So that's correct now. Got there in the end. Now if you remember, we left it in the on position. So this is the non-standby position. And again, that's the same as the off-on switch, as you might imagine. So that goes in like this. Yeah. We may get a bit of a problem here. I hadn't really thought about this. Oh, no, it's going to go in okay. Yeah, I'm going to have to... Yeah, right, so what we want to do is bend these resistors kind of out of the way. Yeah. It's okay. And that can go in there like that. Good. Right, what have I done with the nut and stuff? So let's check this on, that's on, yeah, we're all good to go. There we go. Good, that's done up nicely. There we go. Now I'm just going to check that we haven't done anything here. These resistors aren't going to touch anything. These wires aren't going to touch anything. I'm happy with the clearance between there and there. I think we're good to go. So I guess we can just turn the amp on and see if any of this works. So this should be the on-off switch. It is. The lights come on. I've got the guitar plugged in and the speaker plugged in, so we're kind of good to go when we're ready. Take it out of standby. It's a rectifier valve on this amp. There we go. That's working. Don't forget we've got our light dependent resistor problem, so that's very quiet until I do that. Amazing that. And let's just check it goes out of standby, goes into standby I should say. Yep, that kills it. Hey, job done, nice. So we've got both of our switches sorted there. The next job to do is to think about, so I'm just going to have a little think about whether we can make this photocell area dark. Here by making some sort of little enclosure. On first inspection it doesn't look particularly easy to me, but I'm just going to have a 5-minute thought to think about that. And the other job I want to do is to get the reverb tank out of the case, because we know that the reverb tank is dead on one side, and we'll see if we can work out what's going on with that. Well, to be honest with you, I don't know whether it's worth bothering, but I've made a little doghouse out of 2 pieces of foam board here, some scraps, and a little lid. I've painted the inside black, and that's not totally light proof, but it'll be interesting to see how light proof that is. In fact, let's give it a little go, shall we? Light can still get in this way. I might have a little go and see if I can glue a bit on the side there. Right, so that's a lot louder than it was. Let's see if it goes up in volume when I put this over. No. There's no difference now. There, so that little doghouse has worked. Good. Well, we'll leave the glue to dry on that. Meanwhile, we will take the reverb pan out. We're slowly getting there with this amp. It's been quite a long haul actually, but with a bit of luck, just one more thing to go. Right, I now know why we moved to posi drive screws away from flathead. It took me about 20 minutes to get this out due to this graunched slot head screw. So we'll chuck that away. And let's see what we've got inside this disgusting reverb pan cover. It'll be a reverb pan, of course, but what's the state of it? It actually doesn't look too bad. I wonder if that's been replaced at some point. Now, what is it? It's if it's an Accutronics, then it's been replaced. No, I think this is the original pan. Okay, so we have either a problem with the leads here, or we have a problem with the actual transducers. Let's have a little look to see if we can work out which. Well, one good test would be to get the meter onto the actual transducer itself and see if we have any continuity there. So that's between here and here. Okay, we've got continuity on that side, which I think is probably the drive side because it's got a lowish impedance, 180 ohms or something. So that's probably what's driving the spring. How about t'other side? Right, what have we got here? There and there. Yeah, that's annoying. We've got continuity there too. When I say it's annoying, I mean I quite like to find what the fault is on here. So let's see if that continuity translates itself up to here. Which side is the problem? So we've got continuity. Sorry, I should show you this. We've got continuity on this one. Look, I did test these. I'll be annoyed if this is now working. They actually tested that, so that's very irritating. Right, they're rather similar, those. I would normally expect one to be much higher impedance than the other. That's 171 ohms, which I'd expect to be yes, 171 ohms. I'd expect to be that to be the drive transducer. This one also 170 ohms. Looks like they're using identical transducers on each side. Well, I suppose all we can do is to plug this into our amp and see if it actually works. It didn't when we first tried. Right, the old reverb pan is in, so why don't we turn on and see if the reverb is working before we swap out for this pan here. Reverb's turned up full. Just let the amp warm up. Okay, so the amp's working and we have reverb. I think we may as well just unplug this reverb pan and see what happens when we plug this one in. I don't know which way around to go. Well, that says output. So that's working. Getting any drive though. Yeah. Okay, probably dirty RCA sockets and plugs which I didn't diagnose. After years and years and years of being plugged in, they do definitely become dirty, so I'll put a bit of deoxit on those and try it again. Before I do that, I thought I'd just show you that they have used exactly the same transducer for send and return. So green on the left, red on the right. That's one reverb sound. Swap these over. and exactly the same. There you go, never seen that before. Anyway, I'll give these a clean now. I can see that these are a little bit oxidized, these Phono RCA. I'm going to take a piece of very fine emery cloth and just clean those up, because they are quite bad actually. Just years and years and years of corrosion. It's amazing they last as long. I mean, they're 55, 60 years old now. I'll just wipe that off. That's good, and we'll do the same for the, well, we'll have a look at the plugs here. They don't look too bad. I think a little bit of deoxit on those will work. And of course, working them backwards and forwards a bit like this cleans them up quite nicely. I suspect that's all it was. They'd probably just been in that position for 40 years and 50 years and it just got some corrosion. So that's that side. Now I'll do this side on the reverb pan as well. The amp's off now, by the way. Let's have a quick look what these look like. These don't look too bad, and that's probably because they've been in the casing, in that kind of case. And again, work it round a bit. There we go. Alright, I'm sure that'll work, but why don't we just try it again? Since we're waiting for the amp to warm up, a common problem is these wires here become disconnected from the phono socket, because this is bouncing up and down, look. So it flexes and bends these wires. These have been done rather well compared to modern reverb tanks actually, and often you can just reattach the wire. Alright, well, we've got return and we have reverb. It's not stunning, I mean that's on full, but I guess who knows what it's supposed to sound like when it was first designed. Right, so we are getting somewhere slowly with this amp. The next thing I'm going to do is to clean up this. This is absolutely disgusting. I can't put that back in. Oh look, that's how it's... Just check out what that was. That was a bit fortuitous. Let me just make sure. Interesting. Alright, so we've accidentally uncovered a little problem there by accidentally banging that reverb tank. I don't think it's anything to do with the reverb tank. We've got a connection problem or something here. I'm going to turn the reverb down just to prove it isn't that. Yeah, as expected. So we've got a bit of another problem here. Let's try these valves. Doesn't seem to be the valves. How annoying. Aha. Right. Well, glad I found that really. Have a little waggle around here. This sort of problem can be very, very difficult to find. Annoying. I'm trying to get this amp off the bench. It's really taking up a lot of time for me. I've got amps backed up out of the workshop at the moment. That's always the way. It's a question of tapping around quite delicately to see if you can hone in on the area where the problem is. But of course, you know, if we tap right over here, look, quite hard, Quite sensitive here. You can see the problem. It's pretty sensitive wherever you go. Right, turn off the camera for a moment, get my head in there. Okay, I've been tapping around for about 5 minutes, and I'm beginning to wonder if it's this board here. It seems quite very sensitive, particularly this is the back of the piano key switches. This is very sensitive here. I'll tell you what I haven't done. I haven't cleaned these switches, these piano key switches. Let me make a note of what position it's in. This medium one is in circuit at the moment. Let's yeah, again, these have probably been stuck in the same position for 30 years. Interesting, it goes away when you... Yes, it's only on that medium one there that it does it. And it seems to be getting better. I wonder if I can get some deoxit in there somehow. Let me see, what's the state of these switches? Yeah, they look fairly open to the elements. I'm fairly confident this is the problem though. I wonder if I can just get some... I'm a little bit careful here with this metal can in my hand and then doing this kind of thing. You'll need to touch it against the HT and you'll know all about it. So I've just turned the amp off. Don't know whether I can... Not sure whether this is going in or not. Okay, let's give that a try. This is what it's like, my friends, repairing amplifiers. Fix one fault, 2 others appear, and you have to fix those as well. Has that done anything or not? No, it hasn't. How annoying. Well, it's better. A lot better. I'm kind of thinking this is dirty contacts, so just not quite making. Yeah, see that's okay now. Look, just dirty contacts, been there for many years, probably decades, stuck in the same position. My guess is this amplifier has been in the loft for 30 years with one of these pressed down. There we go. Well, that could have been a lot harder than that, I tell you. I've been there many times before where the slightest touch on a board causes that kind of noise and you just can't nail it down. Good. Where the heck are we now? Phew. It's almost cup of tea time, I think, on this one. We've cleaned the pots. I did all that. We've got the switches in, done all the capacitors we want to do. We've got a little dot. Still not right, is it? Aha! And I can see the fault. I can see exactly what's happened here. Good! Well, I'm glad that kind of went wrong again. Let me show you this. I think those switches were dirty, by the way. But let me zoom in here. I want you to be able to see here. Just pointing. That's where we want to be able to see. Okay, that was the furthest I could focus in without it losing focus. I don't know whether you can see, but this capacitor here has a lead coming out the end of it, which is hooking round and going onto that 100k. That lead is touching this bus bar here. You can actually hear it humming. So we move that away from there like that. Great design, this. And that has sorted that completely solidly. Ha ha! So that was just vibrating and touching this bus bar here. Lucky to spot that. Well, lucky. I touched that and it came and went. Good! Righty-ho, and I haven't been around this area at all, so that's been like that for God knows how long. And just a quickie to show you that the reverb bag cleaned up quite nicely. I just scrubbed it in some hot water with detergent. It's not perfect, of course, but it's a whole lot better than it was. So now I'm going to pop the reverb tank back in there and put the reverb tank back into the amplifier base. Just a very quick final thought. I've got the amp now back into its cabinet, and I thought you'd like to see these two switches. They don't look too bad really, I don't think. That's the on and off switch and the standby switch. I think they're fine actually. So I'm quite pleased I took that decision because they're decent switches, those, unlike the ones that were in there. Well, okay, there you go. Bit of a mission that actually. I was very pleased to get that amp off my bench, as it had been there for, getting on for the best part of a week. Anyway, I hope you enjoyed that. A lovely amp, of course, and a classic in its day. And we did a few things to it. We didn't do massive amounts. We didn't change all the resistors or the valve bases or even the preamp valves for that matter. But nevertheless, a fair old chunk of work. The older the amp is, of course, the more problems you're going to get, and the more stuff that's going to go wrong. But for the budget that the customer gave me, I think we did quite a good job on that. Well, thanks for watching that, and I'll catch you on my next video.